The topic of this video is graphing transformation techniques, vertical and horizontal stretching and shrinking. Okay, let's look at a problem. Consider the graph of f of x shown below. Use the graph of f to create the graph of h of x, which is equal to f of 2x. Alright, so once again, let me share some information with you before we begin. The first thing that you want to take note of here is, in this particular problem, we are not given an equation for f of x. So the level of difficulty of this problem is one notch higher. However, I'd like to give you some advice that I got from a student a couple of semesters ago. Here's what he observed. He observed that the graph that's being provided to us is kind of like an extra basic function that we've just never seen before. The basic functions come with pictures. So try to think of this as a basic function that you've never seen before. It's your starting point. It's the thing that we're going to transform. And even though we haven't been given an equation for this starting point, we have been given a picture with 4 very clearly easy to spot points. Let's make a table of those points now before we even begin to solve this problem. So f of x consists of the following 4 points. We've got -4, -1. We've got this point right here, which is 0, 3. We've got this point right here, which is 2, 2. And we've got this point right here, which is 4, -1. Think of this as your parent function, your basic function, your library function, your starting function. Now, let's figure out how to transform it. All right, we know that we're going from f of x to f of 2x. So we ask ourselves the familiar questions. First of all, what changed and where? And what kind of transformation does that indicate to us? Okay, well, what changed is the 2, and the where is inside close to x. Inside close to x is indicative of a horizontal transformation. And because the change, the 2 is multiplying, that indicates that we are dealing with a stretch or shrink, and it's up to us to determine which one it is. Is it a stretch or is it a shrink? Well, the way we do that is we think to ourselves, horizontal. Those are backwards than what we would expect. 2 is a number bigger than 1. You'd think that's a stretch, but it's backwards, it's a shrink. So this is a horizontal shrink. Now, to get the new points of the new graph, we have to remember that for a horizontal stretch or shrink, it is the x coordinates that are divided by the multiplying number. So our x coordinates here are going to be divided by 2. The y coordinates do not change. So with that in mind, let's go ahead and fill in our y coordinates because they're not going to change. That's not enough of a differentiating color. Let me go to green here. All right, so the y's are not going to change, but the x's are all going to be divided by 2. All right, so -4 divided by 2 is -2. 0 divided by 2 is still 0. 2 divided by 2 is 1. 4 divided by 2 is 2. So this is the collection of our new points. And when we graph them, and then we connect them using our straight edge to make the same kind of shape that the original graph had, we should observe a horizontal shrink. That's motion of all of the points towards the y-axis. Okay, let's see what happens. -2, -1 would be here. Oh, I think I drew the scale wrong on this. Let me just fix that really quickly here. Those numbers are in the wrong place, and that can be a little misleading. So let me just fix that. All right, that's where those values should have been. And I managed to get the coordinates right despite that error. That's a little unusual, but hey, sometimes you just have an instinct about these things. Okay, again, sorry for that small error. Let's get back to where we were. So -2, -1, that would be this point right here. 0, 3, notice that point didn't move. If something is already on the y-axis, it can't get any closer. 1, 2 would be this point right, 1, 2 would be this point right here. And 2, -1 would be this point right here. And notice that that is exactly what we observed. The blue points are all moving towards the y-axis. That is indicative of a horizontal shrink. And since the blue points were connected using a straight edge to form line segments, the green points must also be connected in the same way using a straight edge to create line segments. And this will create the final picture for this particular problem. All right, there we go. We did it. The answer to this question is the green graph only. The blue is just where we started with. So I'll say that again. The answer to this question, creating the graph of h of x, which is equal to f of 2x, is just the green part of this graph. The blue is not part of our answer. The blue is just the parent function, the basic function that we started with in order to create the graph of our final answer.